Dear friends, welcome to Bond with Chemistry YouTube channel. In this video, I am going to explain the previous year questions which are appeared in HCU PG Entrance Examination from the lesson of Electrochemistry from the years 2016 to 2020. Okay, these are the year-wise questions which are appeared in Electrochemistry in HCU PG Entrance Examination. An electrochemical cell involves the self-reaction cadmium plus 2 AgCl gives rise to 2Ag plus cadmium chloride. If E cell is equal to 0.675 volts and dE cell by dt is equal to minus 6.5 into 10 to the power minus 4 volt Kelvin inverse at 25 degrees centigrade, then delta H in kilojoule mole inverse for the cell reaction is closest to. Here we know that delta G naught is equal to minus NFE. Delta G is equal to minus NFE cell. And the delta G is equal to delta H minus T delta S from thermodynamics. So delta G is equal to delta H minus T delta S. And delta H is equal to delta G plus T delta S. From this equation, delta S is equal to, this one is equal to NF dou E by dou T. So delta H is equal to delta G minus NFE plus T into NF. So NFT dou U by dou T or d by dt. This is the equation. Delta H is equal to minus NFE plus NFT dE by dt. Here in this reaction, the number of electrons which are participated in the reaction is N is equal to 2. Cadmium is converted into Cd2 plus. It means the number of electrons which are participated in the reaction is 2. So when you substitute these values, delta H is equal to minus 2 into 96,500 coulombs into G value 0.675 plus NFT 2 into 96,500 into temperature. The temperature is 25 degrees centigrade, so it will be 298 Kelvin into dE by dt is given minus 6.5 into 10 to the power of minus 4. So upon simplification, you will get around delta H is equal to minus 168 into 10 cube joules. So when you convert into kilojoules, you will get delta H is equal to minus 168 kilojoules. Here you will get a coulomb volt. This one is coulomb. This F is in coulomb and this one is in volt. 1 coulomb volt is equal to 1 joule. Okay, after simplification, this many coulomb volts you will get, means this many joules you will get. When you divide with 1000, you will get minus 168 kilojoules. So B is the correct option. The resistance of 0.1 molar KCl solution in a cell is 300 ohm and specific conductance is 1.5 Simon meter inverse. If the resistance of 0.05 molar Nscl in the same cell is 750 ohm, then the molar conductance, okay, these are the units of Nscl is. Finally, you have to calculate molar conductance of Nscl. Before that, let's take this cell. Here resistance is given, R is 300 ohms and specific conductance, that is kappa, is given 1.5 Simon meter inverse. Okay, we know the relation between kappa and this one. Kappa is equal to cell constant L by A 1 by R. From this you can calculate cell constant L by A is equal to kappa into R. So here kappa is given as 1.5 into 300. The units will be meter inverse. So it will be around 450 meter inverse. When you convert into centimeter inverse, you have to divide with 100 centimeter inverse. So you will get to 4.5 centimeter inverse. This is the cell constant. For this, the same cell is used for Nscl. So the kappa is equal to, for Nscl, what is the specific conductance? It will be equal to L by A into 1 by R. So L by A, we have got the 4.5 centimeter inverse into 1 by R, 1 by 750. Okay, you will get 4.5 by 750. This one is Simon centimeter inverse. This is in centimeter inverse. We have to calculate the molar conductance. Molar conductance we have to calculate. So lambda m is equal to 1000 kappa by C, and kappa is in centimeter inverse, Simon centimeter inverse, and C is in molarity. So 1000 kappa 4.5 by 750 into concentration of NaCl. This one is 0.05. 0.05. Upon simplification, you will get lambda m is equal to 120 Simon centimeter square mole inverse you will get. So when you convert into meter square, you have to divide with 120 by, for 1 meter is equal to 100 centimeters, you have to divide with 100 square, and this one will become Simon meter square mole inverse. So finally you will get 120 by 10 to the power 4, it will be equal to 0.012. The activity of K3P4 solution of molarity C and mean activity coefficient gamma plus or minus is. Let's take a salt, an electrolyte, PBQ. This is electrolyte. The activity A is equal to P power of P, Q power of Q, and concentration. Let's take C power of P plus Q, and gamma plus or minus P plus Q. This is the formula. If we take an electrolyte, ApBq. Here, let's take K3PO4. This one, the PO4 is 1. So P is equal to 3, Q is equal to 1 for this electrolyte. So A is equal to P power of P, 3 power of 3, 1 power of 1, and C power of 3 plus 1, and gamma plus or minus 1, 3 plus 1. 3 into 3 into 3, it will be 27, C power of 4, gamma plus or minus 1, it will be 4. So the correct option is D. Given the standard reduction potential E0 is equal to plus 1.23 volt for O2 plus 4H electrons plus 4H plus 4 electron gives rise to 2H2O. The equilibrium constant for the reaction 2H2 plus O2 gives rise to 2H2O at 25 degree centigrade. We know the relation between delta G0 is equal to minus NF E0, and delta G0 is equal to minus 2.303 RT log K. So when you compare these two equations, you will get E0 is equal to 2.303 by 2.303 RT log Kc by NF. Here, what is the E0 value? Here E0 is 1.23. You have to calculate log Kc. Log Kc is equal to NF E0 by 2.303 RT. The number of electrons which have participated in this reaction is 4. So 4, 96,500, and E naught is given 1.23. For this reaction also the E naught will be 1.23. So 4 into 96,500 into 1.23 into 2.303 into, it is in, you have to take in joules, 8.314, and T is 298 Kelvin. So upon simplification, you will get log Kc. Log Kc is equal to, you will get around 83.209. So Kc is equal to 10 power of 83.209. So you will get around 1.6 into 10 to the power of 83. So A is the correct option. The limiting molar conductivity of NaOH, NaF and NH4F are 24.8, 10.5 and 12.5 millisiemen meter square mole inverse respectively. The limiting molar conductivity of NH4OH. From Kohlrausch's law, lambda infinity of NH4OH is equal to lambda infinity of NH4F plus lambda at infinity NaOH minus lambda infinity NaF. So it can be written as lambda infinity of NH4 plus lambda infinity of F minus plus lambda infinity of Na plus lambda infinity of OH minus. This one is minus, so there is a cancellation of Na term and F term. So finally you will get lambda infinity of NH4OH. So for this you have to take NH4F. For NH4F, this one 12.5 plus NaOH 24.8 minus this one 10.5. So 12.5 minus 10.5, it is 2.0, 24.8, it is 26.8. Here the 26.8 is not given, but this one is near to the 26.8, so 27.1 is the correct option. The mobilities of A plus and B minus are 6.6 into 10 to the power of minus 4, 5.7 into 10 to the power of minus 4, and centimeter square, volt inverse, second inverse, respectively at 25 degrees centigrade. The ratio of the transport numbers is transport number of positively charged cation and transport number of negatively charged anion. If you take the ratio according to Hittorf's rule, the ratio of transport numbers is equal to the ratio of their mobilities, U plus U minus. Mobilities are given 6.6 into 10 to the power of minus 4 divided by 5.7 into 10 to the power of minus 4. So you will get 1.16. The ratio is 1.16. The molar conductance of a saturated HCl solution is 130 Simon centimeter square mole inverse, and the solubility product of HCl is 1.6 into 10 to the power of minus 10 mole square later power of minus 2. Resistance of the solution placed in a conductivity cell with cell constraint. Okay, we have to calculate resistance. Before that, we have to calculate specific conductance. Molar conductance is given, solubility product is given. From solubility product, we have to calculate solubility. Here, Ksp of HCl is S square is equal to 1.6 into 10 to the power of minus 10. This is the solubility product, S is the solubility. If solubility is S, this concentration is S, Ag plus concentration is S, Cl minus concentration is S. So the solubility product is S square. From this, S is equal to root over 1.6 into 10 to the power minus 10. This value is around 1.2649 into 10 to the power minus 5. Okay, this is the S value. So we know the relation between lambda m is equal to 1000 kappa by solubility. So lambda m is equal to 1000 kappa by S. That implies kappa is equal to lambda m S by 1000. Lambda ms is 1. Lambda m. What is the lambda m value? Okay, this one 130 into S is 1.2649 into 10 to the power minus 5 divided by 1000. So when you simplify this equation, you will get around 164.437 into 10 to the power minus 8. So this is the kappa value. Okay, we know the relation between kappa is equal to cell constant L by A into 1 by R. So R is equal to cell constant L by A and 1 by kappa. Cell constant is given 0.75 by kappa. 164.437 into 10 to the power minus 8. Upon simplification, you will get around 4.6 into 10 to the power 5 volts. The standard potential of the cell Zn2 plus, Fe3 plus, Fe2 plus, and okay, these are reduction potentials are given. What is the E cell? Okay, E0 cell is equal to this one E0 of cathode minus E0 of anode. Okay, both are reduction potentials. Reduction potentials Rp, and this one also reduction potential. Here this one is cathode, this one is anode. The reduction potential of cathode is 0.777 minus the reduction potential of anode, this one is anode, minus 0.76. So this one is equal to 1.53 volts plus. So D is the correct option. Given the standard reduction potentials at 25 degrees centigrade, E naught A plus A is 0.6 volt and E naught B plus B is 0.8 volt. Predict the spontaneous reaction at 25 degrees centigrade from the following. The more the reduction potential, this one can act as more reduction potential can act as cathode and the less reduction potential can act as anode. We know the cathodic reaction. At cathode there is a reduction. At cathode there is a reduction. At anode there is a oxidation. So for this oxidation is spontaneous. So A gives rise to A plus. For this reduction is favorable or spontaneous. So B plus B. So the final reaction A B plus gives rise to A plus B. So this is the B is the correct option. The standard potential E naught of a given cell is 1.1 volt at 298 Kelvin and dou E by dou T at constant P is equal to minus 6.5 into 10 to the power of minus 5 volt Kelvin inverse. Calculate delta H naught for the self reaction assuming N is equal to 2. Already this type of problem was solved. Delta H naught is equal to and writing directly minus NF E naught plus NFT dou E naught by dou T at constant P. So when you substitute these values, N is to 96,500 plus E naught is given 1.1 plus 2 into 96,500 into T value 298 Kelvin into minus 6.5 into 10 to the power of minus 5. Okay, after simplification, you will get around minus 216 into 10 cube joules mole inverse. We know that 1 coulomb volt is 1 joule. So finally, when it is converted into kilojoules, it will be minus 216 kilojoule mole inverse. So this is the correct option. Calculate the EMF of the cell and the free energy changes associated with the cell reaction for the cell Cu2 plus Ag plus Ag maintained at 25 degrees centigrade. Okay, the Nscl equation we know. The Nscl equation. Okay, the Nscl equation. So this one relates E and E naught. E naught minus 0.0591 by N when temperature is 25 degree centigrade log reaction coefficient, that is Q. Here, what is the reaction? Cu converts into Cu2 plus and Ag plus is converted into Ac. So, Cu plus 2Ag plus gives rise to Cu2 plus 2Ag. Then what is the Q? It's a product of concentration Cu2 plus Ag, Ag square. The activity of Ag is 1. So, this one is 1 divided by this one Cu. Activity of any metal is 1. So, no need to consider Cu and Ag. So, here Ag plus square. This is the Q. So, this is the Q value. E naught. What is the E naught? E naught is E cathode, reduction potential of cathode minus reduction potential of anode. Okay, reduction potential of cathode is given. Here, this is the cathode 0.799 minus 0.333. So it will be equal to 0.466 volts. Okay, E naught is 0.466 minus 0.0591 by N value. Here N is 2 and log concentration of Cu2 plus by Ag plus square. Cu2 plus concentration is this one 0.02 divided by 0.02 whole square. Okay, upon simplification, you will get around 0.412. This is the E value. Okay, 0.412 you will get. And how can you calculate delta G? Delta G naught is equal to delta G is equal to minus NFE. Here N is minus 2, N is 2, 96,500 and E value is 0.412. So in kilojoules, you have to divide with 1000. So upon simplification, you will get around 70 minus 79.5 kilojoule more. So A is the correct option. The ratio of velocities of Ag plus and NO3 minus in aqueous solutions of Ag and NO3 is 0.92. The transport number of Ag plus and NO3 minus are. Okay, actually, according to Hitop's rule, T plus the ratio between transport number of cation and anion is equal to the ratio of their mobilities. Here, the transport numbers of Ag plus and NO3 minus are. Here, velocities ratio is 0.92, so it will be equal to 0.92. Okay, when you divide the first term with the second term, you have to get 0.92. Okay, in this case, you will get 0.92. In the remaining cases, you will get other than 0.92. So this is the correct option. Which one of the following events occur during the charging of a lead storage battery? Okay. During recharge of lead storage battery, These are the equations. Okay, Pb SO4 and takes 2 electrons, and there is a conversion of lead and SO4 2 minus, and in another case PbSO4 plus H2O, this one gives rise to PbO2, let's take 2H2O, and 4H plus and SO4 2 minus, SO4 2 minus. Okay, this reaction, there is a recharging. When there is a recharge, these type of reactions will be taking place. So finally, there is a formation of lead, there is a formation of lead oxide, and also there is a formation of sulfuric acid in the case of recharge. So during the charging of lead storage battery, there is a consumption of sulfuric acid. No, there is a formation of sulfuric acid. There is a formation of sulfuric acid. This one correct. Formation of lead sulfate. There is a consumption of lead sulfate. In charging, recharging, there is a consumption of lead sulfate. And also there is a consumption of lead. This one also wrong. So what is the correct option? There is a formation of sulfuric acid. Okay, here lead sulfate, not lead sulfate, lead. Lead plus 2H2O gives rise to lead O2 plus 4H electrons. This is the correct one. So there is a conjunction of lead, there is a conjunction of lead sulfate, and there is a formation of lead dioxide, and there is a formation of sulfuric acid during charging. If you take discharge, the reactions will be reversed to the recharge. So the correct option is formation of sulfuric acid. In coming video, I will explain the questions which are in the year of 2010 to 2015 from electrochemistry in HCU PG Entrance Examination. Thank you.